antibodies produced ordinarily by infection or immunization are polyclonal because natural antigens have multiple epitopes, each of which generate clones of lymphocyte. These result in anti-sera containing antibodies from different clones of lymphocytes with specific against the different epitope of the antigen. On the other hand, monoclonal antibodies are monospecific antibodies. These antibodies are produced from clone of a single lymphocyte directed against the single antigenic determinant or the epitope. The concept of monoclonal antibodies is first time given by the research started by the Mehrling and Kitasiato that found the rabbits that are immune to tetanus had substances in their blood capable of the destroying tetanus toxin. That is also called as an antitoxin. Then the research is continued by the Magic Bullets in 1928. Okay, and the last monoclonal concept of the monoclonal antibodies is given by the scientists Kohler and Milestone in 1984, and they were awarded by the Nobel Prize. Okay, so here is the basic difference between the polyclonal antibody and monoclonal antibody is given on the basis of useful antibody content, then the composition, then the specificity, cross reaction with the other antibodies, classes and subclasses of antibody, and supply. For example, if we consider a useful antibody content, it is a low in polyclonal antibody and high in monoclonal antibody. The composition of the polyclonal antibody is heterogeneous and the composition of monoclonal antibody is homogeneous. Then the polyclonal antibody shows the multiple specificity, whereas monoclonal antibody shows the defined or consistent specificity. Then if we say about the cross reaction, okay, so polyclonal antibody shows the partial weak antigen carrying a common antigenic determinant, whereas monoclonal antibody does not show the cross reaction, that is the absence of cross reaction is observed. Then about the class and subclasses of antibody. So polyclonal antibodies has typical mixture of classes and subclasses, but monoclonal antibody, as per its name suggests, they have the only one. Okay, and the supply of the polyclonal antibody is limited, but the supply of monoclonal antibody is abundant. Next is the hybridoma technology. So hybridoma technology is a method of forming hybrid cell line by fusing a specific antibody producing B cells with myeloma cells. The antibodies produced by the hybridoma are all of a single specificity and are therefore monoclonal antibody. The production of monoclonal antibody was invented by the Milestone and Kohler, which we already discussed. Okay, so what is the exact principle of the hybridoma technology? So first, what is meant by hybridoma? Hybridoma are a somatic cells hybrid produced by fusing antibody forming a spleen cells with the myeloma cells. Antibody producing B cells normally die after several weeks in culture in vitro. Therefore, antibody producing B cells are fused with the B cells. Okay, fused with the B cells tumors, that is also called as a myeloma. Okay, the next step is the selection of hybrid cloning by dilution, screening, production. Okay, so this is the protocol of the production of monoclonal antibodies. Okay, so after the formation of the myeloma cells, okay, you can see here is a fused hybrid cell, that is the myeloma cell. Here is the unfused myeloma cells, and the uppermost portion is the unfused spleen cells. Okay, so these fused myeloma cells is then transferred to a medium in which only So these myeloma cells are capable of dividing indefinitely and are therefore often called as immortal cell lines. These cells line result from the B cell myeloma fusion of hybrid cell lines with hybridomas. Okay. So after that, the cells are hybridoma cells which can grow are selected. Other are die. Okay. So these selected cells, for example, from the well number 1, 3, and okay, that are selected, and the selective systems involve the inclusion of the antibody aminopterin in the growth medium. Okay, so how this selection is done? So aminopterin is added in the growth medium. This inhibits the de novo nucleotide synthesis pathway. Normal animal cell synthesize purine nucleotides and thymidine for the DNA synthesis by the de novo pathway requiring the tetrahydrofluoride. Aminopterin act as an antifolate drug, blocks the activation of tetrahydrofluoride. However, normal cells survive in this medium as they are able to use the salvage pathway for nucleic acid synthesis. But if the cells are unable to produce the enzyme hypoxanthine guanine phosphoribosylate transferase, that is the HGPRT, they are unable to utilize the salvage pathway and therefore die in aminopterin containing medium. And this strategy mostly used for the monoclonal antibody. In the procedure, myeloma cells are engineered to be deficient in enzyme HGPRT. After fusion of lymphocytes with the HGPRT negative myeloma cells, aminopterin containing medium supplemented with the hypoxanthine thymidine to ensure an adequate supply of substrate for the salvage pathway, okay, which kills the myeloma cells but allows the hybridoma cells to survive as they inherit HGPRT from the lymphocyte parent. Unfused lymphocyte die after a short period of culture, which result in pure preparation of hybrid. This is the procedure of the monoclonal antibodies. Okay, so here is the pathways also given. Okay, next one is the applications. Okay, so these applications of monoclonal antibody includes synthesis of immunotoxin, then the chimerized or humanized antibodies, okay, then the bispecific antibodies. This is about the